Uh, Welcome all the students once again in our fifth chapter, heat. Today we will discuss the content or latent heat and regulation. What is meant by latent heat and what is meant by regulation. But before that, we have to starting. We have already seen that there is a transfer of heat in the form of a conduction, convection, and radiation is there. And this thing we already studied in the 9th standard. And what are the different there is a experiment regarding with the expansion and contraction of a solid, liquid and gases. This experiment we have to also studied in the 9th standard. So we have to proceed further in that thing that what is meant by latent heat and regulation is there. So before that, what we have to do, we have to they have asked some questions regarding with what is the difference between the heat and temperature. So temperature is a quantitative thing, that the how much amount of thermal energy possessed by the object. Okay, and the heat is we know that heat is the form of energy which having there are in the object there are large number of tiny particles are there. These are molecules are there, and they having a kinetic as well as a potential energy and total energy which the object possesses is it's a thermal energy. Okay, and these particles are come in contact. The two different particles are come in contact with each other. We can found that there is a transfer of energy from a body of a higher temperature to the body of a lower temperature. That is heat exchange theorem, and this theory and this transfer of energy, and we can easily find out there is a heat exchange through that bodies. Okay, so we have to start today's topic, heat. The first one is latent heat, and after one we have to see the regulation is there. So for that, the latent heat is the amount of energy provided to the particular phase of a matter, so that we could not identify, that we could not see the temperature of the body rises at the situation, but this type of a heat which it gains, the object gains, is utilized from some sort of work done. Okay, and this thing we have to study in a latent heat. In today's experiment, what we have taken in a laboratory, we have to take a beaker of a glass. One beaker is there. It is filled with ice cubes, means pieces of ice. Okay, small pieces of ice are there. We have to insert a thermometer is there. Thermometer is used to measure the temperature of that mixture which is made afterwards. Here is solid cubes are there, and there is a transfer of this solid phase to liquid phase. That means it is a mixture of water and solid ice is there. Okay, so what you have to, we have to measure the temperature. Okay, we have to measure the temperature, and for to measuring the temperature we have to use a thermometer. Okay, so degree Celsius, we know that the unit of a temperature is degree Celsius, and by using that we have to proceed further. Here is a burner is there. So what is the purpose of burner? Burner is to utilize the amount of heat to the beaker. Okay, it utilizes the amount of heat. It is transferred from burner to beaker, and beaker through ice cubes. Okay, so after getting the heat, after it absorbs the heat, there is a transfer of phase, solid phase to liquid phase. Okay, liquid phase to gaseous phase. So what you have to do, we have to provide it some sort of amount of a heat energy. We have to provide a heat energy. heat energy, and this energy is converted. This heat energy converts the different phases. That means a solid to liquid, liquid to gases. Okay, and this we have to study it here. So in our experiment, we already discussed those things. Take a beaker. We have to add some amount of small pieces of ice cubes or ice pieces are there, and we have to insert the bubble of the thermometer. So bubble is here, so that due to when it gains the heat, there is its temperature rises, and we can easily see in the thermometer. Okay, so these are the initial arrangement we have to make. Here is a stand, and we have to adjusted a thermometer in a beaker, inside the beaker where the ice cubes are placed. Okay, so what you have to do, we have to make this arrangement, and after that we have to measure a temperature of every single minute. We have to measure the temperature of every single minute, that the record the temperature is in the thermometer, and every minute they have to already told to us when ice is heated. They have been shown that the ice is heated, it starts melting. Okay, so all these ice cubes are melted slowly. Okay, we have to stir it. We have to stir this mixture which is made. Some amount of ice cubes are melted, and the remaining ones are floating on a water. Okay, on the surface of water, because they having a very low density. And what you have to do, we have to stir it so that the heat energy is uniformly distributed, so that all these ice cubes or pieces of ice is melted. Okay, so you have to measure the temperature. We have to measure a temperature on y-axis in degree Celsius. Okay, 10, 15, 100 degrees Celsius. We have to see the temperature. Okay, we have to see the temperature corresponding to time. We have to corresponding time means 1 minute, 2 minutes, 8 minutes, 10 minutes, 15 minutes, 30 minutes. According to time, how the temperature of the thermometer rises, and these graph we have to draw here. We have to draw the graph of temperature versus time. Okay, because there are some sort of phases are there. There are some constant temperatures are there, and these phases we have to mention. We have to study. Okay, so now we have performed this. Experiment. You have to reading. We have to note down the reading of the temperature and the time, and after that we have to notice that when temperature if the ice cube, these substances are getting heat from the burner, temperature remains same. The phase A to B, the temperature remains same in a thermometer, that is 0 degrees Celsius. Okay, at this phase, at this situation, all these ice particles means ice pieces or cubes are melted. These are the situation which happen there. It absorb energy, heat energy. Okay, heat is some sort of energy, you know that, and this after the absorbing energy, they are transformed from solid state to liquid state. Okay, solid state to liquid state. So here A to B, without any rise in temperature, that is 0 degrees Celsius, all these pieces are converted into water. At a constant temperature, that is 0 degrees Celsius. Okay, these are the phase from A to B. Okay, after that, after transition of a solid substance, that is ice cubes, into liquid, that is water. Okay, after a liquid phase, all these liquid particles, the substance which absorb heat once again, we have to continue the heat provided to that particular substance, that is afterwards is water. So water gains the heat energy. Okay, the temperature slowly rises, rises up to 100 degrees Celsius. Up to 100 degrees Celsius, that means the phase from B to C. Liquid absorbs some sort of heat energy and temperature rises from 0 degrees Celsius to 100 degrees Celsius. This phase to this phase and this to this, solid to liquid up to liquid to gaseous state. Okay, the temperature rises. This is a liquid state. Okay, and afterwards at a constant temperature 100 degrees Celsius, when the boiling water is there, it gains some sort of energy which is required to escape from this state, that is liquid state to gaseous state. And at a constant temperature, all these water particles are converted into a gaseous state, that is in steam, at a constant temperature. Okay, so there is a transformation of a liquid phase to gaseous phase at 100 degrees Celsius. So there are we have already seen there are one phase A to B. Okay, in A to B, what you have to see, we have to transition period from a solid state to liquid state, Okay, so here we have in a liquid state all these ice cube melts. Okay, so after that B to C is the stage or a phase where the temperature rises. It comes toward it rises in such a way that up to the 100 degrees Celsius the water boiling begins. Okay, so it converted and it rises to 100 degrees Celsius, and after that there is once again one phase, that means liquid phase to the gaseous phase, liquid to gaseous. There is another transition phase is there at a constant temperature, that is 100 degrees Celsius. So that two phases are there, solid to liquid, and temperature rises, and after that liquid to gaseous stage. Okay, so we have to see there are some something regarding with it. They already told us that at a temperature remains a constant. Temperature remains constant in the segment AB. So we have to find out a definition. So what we have to find out the definition of a melting point. Okay, melting point of ice. Melting point of ice. So what it states, the definition states that at a constant temperature at which ice converts into a water is called the melting point of ice. At a constant temperature there is a transition of ice. There is a transition there, ice is converted into water, that means transition of ice into water, and this constant temperature is called melting point of ice. So melting point of ice is at a constant temperature there is a transformation of ice into liquid state, that means water state, and this constant temperature is called a melting point of ice, and that melting point of ice is 0 degree Celsius. 0 degree Celsius. So after that we know that in solid state to liquid state, they have already gained some sort of energy. They already gained some sort of heat energy from the burner. So where is that energy? Where this energy goes? So one question arises there. So we already know that there are some sort of a they have told us that there are some this object absorbs energy. So the molecules content, the particle content, it gains energy, it absorbs the energy, and they have been utilized this energy. The conversion, this absorbing energy, heat energy that they absorb, that ice cube absorb, they have been utilized for the transition state from a solid to a liquid. The molecule which contains atoms and molecule which contains in the solid cubes are utilized this energy in the formation of a solid state to water state, that is liquid state. So this energy, the molecules, the atoms which are binding with each other, and after getting the heat energy, the bond between them is weak. The bond between them is weak. So the binding between the molecules or the atoms which is all in it, the strength becomes weakened, and the weakening this strength, and the cause behind it is that the energy which is provided to it, they absorb it and they have to utilize this, and after that the bond between their molecules, their atoms, it becomes weakening, and after that bonds became weakening, and it transform into solid state to liquid state. So even though temperature not rises in that phase A to B, the heat energy is provided to it, but temperature is not rises. So this energy goes. This energy it utilized to weakening the bond between the atoms and molecules to break up this bond, and there is a transition period starts. From solid to liquid. So that there is a latent heat. The concept latent heat, the energy which could not see on the thermometer. The temperature is not rises, so energy where it goes, but energy we cannot easily see on the thermometer. This is utilized to transform one stage to another stage, that is from solid state to liquid state, that phase, transition of a phase or a transition of a state. Okay, so this is called latent heat of a fusion. That is called a latent heat of a fusion. Latent heat of fusion is the energy. In a latent heat of fusion means there is amount of heat that ice cube absorb, and this heat is utilized for the transition of a solid phase to liquid phase, solid state to liquid state, and the amount of energy to utilize, to work done to break up this bond, to weakening the strength, and this type of energy, this is called latent heat of fusion. This energy is called latent heat of fusion. Okay, so here is a definition. We already seen the amount of heat energy absorbed. The amount of heat energy absorbed at a constant temperature. The amount of heat is absorbed at a constant temperature by unit mass of a solid. by unit mass of a solid. The amount of heat is absorbed at a constant temperature by unit mass of a solid to convert into liquid phase. Solid phase to liquid phase. The amount of energy absorbed by this object at a constant temperature to transition of solid phase to liquid phase, and this is called a specific latent heat of fusion. Specific latent heat of a fusion. So the specific latent heat of fusion is that type of energy, that energy absorbed by the object at a constant temperature by the unit amount of a substance, unit mass of a solid, that is substance, to convert solid state to liquid state, the solid phase to liquid phase, and it is called a latent heat of a fusion. Okay, so after that latent heat of fusion, here is a temperature rises from 0 degrees Celsius to meantime temperature rises. Okay, latent heat of fusion already we have seen. The temperature rises from 0 degrees Celsius to 100 degrees Celsius. Okay, in that period its kinetic energy increases. There is a vibrations of a particles, and they are more excited to break up the situation, and they are transformed. They are another transition state, liquid state to gaseous state, and so it happens at 100 degrees Celsius. Another state, that is latent heat of vaporization. Okay, so another stage is there, another phase is there, where the water is converted into gaseous state. That water, the phase of liquid phase to gaseous phase, and this phase happening at 100 degrees Celsius. That means the energy absorbed by a water or a liquid phase, okay, at a constant temperature by unit mass of a liquid to convert into a gaseous state, and it is called a specific latent heat of vaporization. That is called a vaporization. Vaporization. Okay, so here is also another state is there, that instead the amount of heat energy is absorbed by the liquid at a constant temperature by the unit mass of a liquid to convert to liquid state to gaseous state, and this is nothing but the latent heat of vaporization. The amount of energy is, even though we have, by using this burner we have to provided a lot of amount of heat energy, but this heat energy is utilized to change the state, to change the phase, and this is called latent heat of vaporization. So before that, what is meant by a boiling point? Another definition is there. What is meant by boiling point? Boiling point is at a constant temperature. They have given that at a constant temperature which liquid transform into gaseous state. At a constant temperature, liquid transform into gaseous state. That means one phase to another phase, liquid phase to gaseous phase, and this temperature is called a boiling point of a water. Okay, so we have seen the melting point of a water, ice, melting point of ice, boiling point of water. Okay, another one is latent heat of fusion. That means transition from a ice to water, and afterwards latent heat of vaporization, that is transition period from water to gaseous state. So there are 4 definitions we have already seen here in the regarding with latent heat, and also melting point and boiling point. So another thing we have to discuss. another thing we have to discuss today is regulation. What is meant by regulation? So in a short, here is a diagram in our book. Here is a diagram in our book that on a table, here is ice slab is there. Ice slab is there, and what you have to do, we have to take a wire. They have given that there is a thin wire is there and two identical weights are there. These are the two identical weights. It is kept on a table. Okay, all these on a table. We have to take ice slab is there. Here is a wire is there, metal wire is there of iron. Okay, iron wire is there and two identical weights. Okay, so there is initial arrangement we have done in the regulation. Ice slab we have to keep on the surface of the table. Ice slab is there. We have to take iron wire is there. Iron wire is here, and these a same amount of length we have to take in either side and both sides, and we have to attach a same weight. Identical weights are on both sides. Why it is identical? It is, if these two are not identical, then the shape is like that. It is tilted, more pressurized on the weight in which side they have been attached. So two identical weights are there, and we have to attach the weights, and we have to do initial procedure. So what happens is there, these metal wire penetrates. These metal wires are penetrate. Penetrate means they are inserted, and they actually coming from this point to this point. That means it break the ice. By step, but without break down the ice slab. It moves from this point to this point. So this is the regulation. That is the regulation. So regulation is the phenomenon in which ice converted into liquid. And once again liquid due to the applied pressure and reconverts to ice. When pressure is removed. When applying the pressure, what happened there actually? By applying this pressure, we know that iron wire is attached by using the two identical weights are there. So due to that, there is a pressure applied on the glass slab. So after applying the pressure, their melting point lowers. Okay, it lowers the melting point, so that lowering melting point, the surface in contact, ice slab which in the contact with the iron wire, so the melting points lowers, so that the connecting or contacting the surface melts. So it converted into water. The ice which is contact with the wire is converted into water. So it penetrates. This iron cable or wire. It penetrates through it. Okay. So it moves downward. Okay, it moves downward. But after that, the amount of water, the conversion of a ice into water. So this water is once again, after releasing the pressure, their melting point is as usual at 0 degrees Celsius. So that it converted into ice. The water which is first one is converted into ice is converted into water, and after that water is converted into ice. So that due to the pressure, its melting point lowers, and so that it melts, and after that melting in such a way that this iron wire is penetrates through the glass slab without breaking the ice slab. And this phenomenon is called a regulation. So here we see the regulation is the phenomenon in which ice converts ice converts to liquid due to the applied pressure. Ice converted into liquid. Ice converted into liquid by applying pressure due to applied pressure, and reconverts to ice after removing pressure, and this is called regulation. By applying pressure, it converts to ice to water. After removing pressure, it converts to water to ice. Okay. First one is ice to water by applying pressure. After removing pressure, it converts to water to ice, and this is called a regulation. So I just stop here. We have discussed latent heat of vaporization, latent heat of fusion, melting point of the ice, and boiling point of the water. These are the definition we have studied in a chapter heat. So I can stop here. We have to proceed in next lesson.